So let me keep my introductions here. You can see my screen now, Dhiren?
Yes, Amit. Yes.
Are you able to see? Okay. So what we'll do today, like we'll start a Scala basic programming. Okay.
Okay.
So as of now, we have completed how to create a project structures and what is the requirement we should look up. And based on that requirement, what are the softwares we required that we have discussed in the last class.
Yes.
So today we'll start basically the basic programming in a Scala. So let me take up your screen. Right, you can see right my
Yes.
notebook.
Yes.
So let us start with basic programming here. So the first concepts comes exactly the data type. Data type.
Yeah.
So it is same data type like other programming language. There is no change. Like C, C++, Java,
Okay.
Python, whatever programming we have, right? Like
Yes.
integer, float. Difference is that all the data type is a class here, like integer, double, string. Everything is a class in Scala. Okay.
Okay.
Here, like yeah, the declarations of variables. How do we declare the variables here? The two way we can declare. One, we use the var keyword, which is known as what? Mutable, right? Mutable variable. So mutable variable means the value can be changed, but not the data type. Okay. Why?
Yeah.
As we have discussed in the last class, a Scala is what? Type safety language, correct?
Type safety languages.
Okay. So it means if I'm declaring the var a colon integer is equal to 10, if you are changing this value a is equal to 22, it is correct. It is true. It can be changed. But when we are trying to change the value here, a is equal to 22.22, it is not possible. So it is what? Type mismatch.
Type mismatch.
This we have discussed, right? So let's see
Yes.
one more time in the Scala prompt here. So if you see right now, a
Yeah.
Scala, if I declare the var a is equal to 10, a integer 10. So a is an object of integer class, right? Integer class
Yes.
here in a Scala. A is an object of int which has the value of 10. So we have discussed about Java virtual machines. So what will happen? Whenever we are declaring a is equal to 10 in a Scala, this a is an object of the type of heap memory in JVM. And that a has the value of 10.
10.
Now, when we are trying to change this value is equal to a22.22, which is a double type, not possible. So what we are getting here? Type mismatch, right?
Type mismatch. Yes.
So if the value is a similar type, right? Then value
Yeah.
can be modified. A is equal to 32. Yes, is possible. Why? Because it is also type of the integer value. So if we are declaring any variables in a Scala using the var keyword, which is known as mutable, means value can be changed, but not the type of value can be changed.
Got it. Yeah.
So in this case, we use the requirement word var keyword in a Scala. That is the requirement. Second keyword we discuss exactly, you use your val keyword, okay?
Yeah.
Which is known as immutable. Immutable variable means either value or type
Cannot be changed.
cannot be changed.
Okay.
Okay, right?
Yeah.
So in this case, you can see here, if you are declaring the variables here, the val keyword val a colon integer is equal to 22. So it is like what? Constant now, or similar to final in other programming language, correct?
Yeah.
So in this case, yes, if you are trying to change the value of a, that is also not possible here.
Possible.
Let's say here, like the val is integer, a integer is equal to 22. Now I'm trying to change 32, not possible. So what it is we are getting here?
Re.
Reassignment to the val, right? So
Yeah.
what it is saying here? If you are trying to change the value itself for the val keyword, that is not possible because it is a constant, it is a fixed, it's a final, right? Okay, it cannot be modified or it cannot be changed either the value or data type if it is a val keyword, if you have declared any variables using what val.
Okay.
So that's why this is known as immutable type of variable in a Scala.
Okay.
So this is the two keywords generally we use here. Next is that exactly, next I'm coming to here object, okay, a Scala object. Okay, detailed discussion. Now, in a Scala object, like the concept behind this exactly here. If we are going for any other programming language, let's say like if I'm coming for Java or Python, okay, I'm comparing here.
Yeah.
Okay. So there's one requirement. What is the requirement in this programming language? Let's say I have a 5 class. Okay. So class, let's say like department, class project, class employee, okay, and class, let's say like company. Fine.
Okay.
We have now 4 class. What is my requirement? I want basically 2 requirement here. First of all, I don't want to create object for department. We are not. We don't want to allow to create any object for department. Similarly, see the requirement. My requirement is that I want that no one should allow, okay, not allow to create any object. You got the point? First requirement. Second requirement is that I want for the employee and the company, okay, any it must have only one object. One object. What do you mean about this one object? Means we cannot create more than one object. Okay.
Okay. Hello?
Yeah.
Yeah.
So in this case here, you can see right now. So this is my requirement, correct here. It must have only one object. We cannot create more than one object. That is my requirement, correct? Now, class project right here.
Yeah.
We can create many objects. We can
Create menu.
create many. We have discussed what is class, what is object. Didn't?
No.
Oh, okay. I'll be back. Okay. So in these cases here, this is my requirement in any programming language, not only Scala, Java, Python, or Scala. Okay. So let's say in Java and Python, what we do for this. So for this, what we have to do, we have to make the solution is that in this programming language, okay, we need to create singleton object. So if there is a singleton object for the class, we cannot create second object, third object of the class. That is the principle, okay, as per the logic. But to create this singleton object, we have to apply some policy. We cannot directly say every object is a singleton object, right? So there is some rules, some policy need to be applied on the program, right? We have to apply some policy on the class to create what? Singleton object. That is the one. So to apply some policies means we have to write, at least we need to follow steps to write class for creating what? Singleton object. Clear now? Here?
Yeah.
So that is the steps. It means at least we should write, we have to write 10 to 20 lines of code here. 20 lines of code. Now let's see example. Class or object in Java. Okay.
Yeah.
Singleton. Let me keep object. Okay. So for that, we have to make a singleton class. Example will come to know. Just I want to show you some program here, okay, to understand. So if you come here, singleton method design pattern. Now let's not go to design pattern. Yeah. You see here, Java singleton pattern implementation, correct? How to apply singleton technique to create a singleton object, correct? Okay. So in this case, first we have to initializations here. So what it is showing here? See, we have to class, whatever the class we are going to create, that class variable we have to declare with a static and final, correct? Private, right? We have to make it. This is the first principle. So the policy, right? We have to follow as per the Java. I'm not talking about the Scala right now. So don't be confused. Just you understood. If you are going to create any singleton object or to be defined in the class in Java or any other programming language, we have to follow some of the rules or policies step by step to make it a singleton, correct?
Yeah.
Then get instance method, right? Static block initialization, right? That is another, right? A static block initializations here. Singleton, right? Static block singleton, correct? The static block singleton, right? You can see it.
Yeah.
After that, what? Then what? Lazy initializations we are doing here. So finally, threads of singleton here. But I'll show you the program. This is not correct for you. Okay, this is looks complicated for you. Singleton object example. Let me check here. Yeah, see that I have a class singleton. What I'm doing, I am creating what? The static of one of the reference variable.
Yeah.
Okay, this is the reference variable, right? Here. See here, the stat singleton and variable, right? Singleton is my class. This is my reference variable of the class. After that, what we are doing? We are creating the constructor, and then you can see here what function I'm calling. Create instance. Methods to create instance of the singleton class, right? So this is the static, right? So these are the policy we have to follow. That is my point here. So it means if I want this class should have only the singleton object, it means we have to follow some of the policies in the step to make it the singleton, correct?
Yeah.
We cannot create multiple objects. Basically, the idea behind this here. We have to allow only one object right here of the class here. Okay. So in these cases here, what happened? We have some lines and some policies we have to follow here. But in a Scala, just we are giving what? Object. Okay. And let's say I am giving what? Company. That's all. So by default, okay, in a Scala, now this is our Scala. Okay. So in a Scala, by default, it is singleton. You got my point? In a Scala, by default, it is what? Singleton. What is singleton? A Scala object, right? What you're talking, right? A Scala object, right? Yeah. So what is a Scala object now? Is company. So this company is a singleton itself. We don't need to write any constructor, any policies, any code for that, right? See that? It is just one word, right? But if you are moving to the other programming language, we have to follow some of the policies and principles to create one singleton design patterns to create one singleton objects for the given class, correct? So simple in a Scala.
Yeah.
So it means, let me back here. So let me go to the back here. Scala. So in these cases, we are now. So this object, right, the company singleton object. So just now we have seen in this online platform, it is a static, right? See that? Static, correct?
Yes.
Okay. And the variable is also what?
Static.
Static, correct? So what do you mean about static? Any idea?
We cannot change the value of it dynamically during the runtime.
No. We can change the value of the static, but the difference is that I'll explain you, okay, today. I'll make clear, okay? So object is now, by default, this singleton object, right, the company is what? Static. Okay. So if it is static, means all the methods, right? See that, remember this words, okay? Thumbs rule. All the methods are variable defined inside the Scala object is what? The static in nature. So we are not using any static keyword, right?
Yeah.
You got the point here? We are not using any static keywords. It is already in the nature, right? It is static here. Is this clear now?
Yeah.
I'll be back in a static shortly.
Yeah.
So the first of all, we understood exactly in a Scala. Let me come back here. If I'm going to the Scala, new Scala class, correct? This we have discussed.
Yeah.
When I'm going to come in here, what I'm selecting here? A Scala object, and I am giving here company. What I'm giving name? Company. This object, right? I'm talking. This object, company is what? Singleton in nature by default. And internally it is static. Correct?
Yeah.
You got the point?
Yes.
And I discuss extends app?
No. We did not discuss anything.
Okay. I got it. No, just I'm asking you because I'm taking like many classes parallelly.
Yeah.
That's why. Okay. So extends app. So I'll be back shortly, okay, on extends app. So the first of all, what we discuss, this company is nothing but Scala object, right? As per the Scala, which is by default singleton in nature. Singleton in nature means it is static, right? As well as a singleton, correct?
Yes.
So what we can say now, based on these discussions, what we are saying here, this company, right? This company, exactly whatever you are talking here, are nothing but singleton plus static. So singleton means we cannot create now any more object, right? Singleton, right?
Yes.
Okay. Plus what? Static. Is this clear now? The flow?
Yeah.
So in a Scala, first of all, if you are going to create any Scala object, okay, by the program, whenever we are going here, again, I'm coming back, a Scala, new, class, object, right? Whatever object we are going to create here, like employee, okay, any object, by default, it is singleton plus static. Is this clear so far?
Yes.
Okay. Now, so if it means what I'm trying to say exactly here, I'm trying to say here all the functions and all the methods, whatever variables, right, we are declaring in this class, any object, right, inside the Scala object I'm talking. Okay, all the methods or variable defined inside the class is what? A static in nature, correct?
Yeah.
By default static. We are not giving any static keyword. Okay. Now let's understand this part. Okay. Before going to that, let me explain you the extends app. So any program, okay. So we have got another requirement here about app, right? In a Scala. So it is a trait, okay. It is trait in a Scala. I'll come back in upcoming class, Dhiran, okay? Not today. Otherwise, you will divert the flow.
Yeah. Yeah.
So what this trait has exactly, it has, okay, defined main functions which is final. So what is the meaning of the final main? So what is the logic? If any function, right? If any function is final, right? Final functions which cannot be override or overloaded. Okay, you got the point here?
Yeah.
So that's why in a Scala, what they have done, the main function, right? Whatever we use C, C++, Java, Python, main functions, it is by now in a Scala, if you are going to use app, right? Trait in my object, it means the main functions is a final which is being called internally here. So let me show you right now. We go control and press here, okay? We'll come to know this one, right? See that. This is the library, right? What I'm talking here. This is the library. See that? So the main function is defined here, correct? Final. So this main function is a final, means these functions cannot be override anymore, cannot be overloaded also. Okay. By
Yeah.
default, if I'm not using this app, okay, suppose if I'm not using app here, correct? I'm not using app. Let's see here another solutions. So what I'll do here, I'll go to highlight main. You got the point here. But this main function is like common main function which we have used in C programming, C++, Java, Python. It means this main function is not the final main function. This is the normal main function. These functions can be override. It's a technical interview questions. Can we override, overload main functions in Java? Yes, we can do. But what about in Scala? No, we cannot. Why? Because we prefer to use extends app, right? Only this is the point difference here. I can use both. Okay, I'll be showing you. You got this point here, Dhiran?
Yeah.
Doubts? Or do you have doubts?
No.
So only point is that we can use both. Okay, we can use either extends app. Okay, so what we can do? So we can use object hello extends what app. In this case, we don't need to write any main function, or we can use here object I, and I don't want to use the extends app, then I should write here def main functions here, right?
Yeah.
Okay, and this main function. So if you don't want to use the main function, then we have to use what extends app. If you want to use the def main function, then you have to use this normal, right? The normal programming, whatever we do. But in a Scala, it is recommended to use the extends app because this function is what final, right? You got any questions here?
No.
Okay. So we discuss now. So now I'm coming to the static part. So what happened like here? We have discussed about Java virtual machine.
No, Amit.
Okay. Okay. So let me tell you here. So let's say here, if I'm declaring the var integer date, okay, is equal to 5.5. Then if I'm declaring the var integer loan rate, okay, loan rate here, okay, 6.5. Fine. After that, I'm defining one function here display is a function here in a Scala. And here I'm writing println welcome to a Scala static session. Okay, let's see here. Now I have this variable 5.5, 6.5. Then we have a display functions. Okay. Now let's say what I'm going to do here. I am going to call this display method, right? Am I calling any object here? No, right?
No.
This functions directly is being called itself in a Scala. This is the defining the function. This is the calling function, correct? This place.
Yes.
Inside the object, inside the Scala object, right?
Yes.
So what we are doing here, we are defining what? Functions inside the Scala object. And here what we are declaring, what we are doing here? Here we are declaring variable, okay, inside the Scala object. Clear now? And that is what? That is what company, right? The Scala object name is what?
Company.
Okay, which is by nature is a singleton as well as a static, correct?
Yes.
So what we discuss? So I told these two variables, interest rate and the loan interest rates, right, will be what? It will be also a static in nature, right? Then I told these functions, which is a part of your Scala object, it will be also static in the nature because these variables and this function is a part of what? The Scala object company.
Object company.
Right? Clear now?
Yeah.
Okay. Now, if I'm going to call this function, right? Calling.
That is the syntax, is it? I mean, define display unit is equal to, that equals to means that's the syntax, is it?
So here, yeah, it's a syntax in a Scala. I'll come back in functions, not today. Otherwise, you know, everything will get messed up. We have a lecture function separately, but the logically define, this is the same syntax we use in Python also and other programming. Functions name, call an unit. Okay, this is the new things we have got. So generally in other programming language, what we do, we write like this, the def void something like this, right? We use, right? Display, correct? But in a Scala, what you are using? Reverse. Def, this, colon, return type.
Okay.
And then equal to my body of the function. This is the flow. Okay. What is unit here? Unit is nothing but like void in other programming.
That's a that's a keyword, no, is it? Unit?
That's a keyword, this class. Okay. No return type, right? It's a class. Unit is a class.
Okay.
Because we have discussed in a Scala, everything is a class and object, right? Nothing beyond that, right?
Yes.
Like integer, double, float, string, all are class. Similarly, unit is also class. Even app, right? What I told, it is a trait, right? Okay. State is also class, we can say. State is also class right now. So that's why they have given this syntax. If you're defining any function in a Scala, we have to follow these patterns. Def keyword, function's name, colon, return type, equal to, and then braces. And here we write the logic, right? We write what? Logic.
Yeah.
Clear now? These points?
Yeah.
Okay. Now what I'm doing here? I am calling the functions and variable to use in my program, correct? So what I'm saying, I'm calling display function. Let's run company. Run company, right?
And then when we define the variable, right, Amit? So now int rate and loan rate. So we do not have to specify the data type, is it here?
No, we must specify. That is a good habit, right? Best practice, correct? So we can give here. Generally, we have to follow this flow, right?
Okay.
Okay, it's a good habit, good practice. If you're not giving, it will make it a double, but that is not recommended, okay, as a best practices, okay?
Okay.
Okay, so now we got here. Welcome to Scala static session. So are we using any object here? No, right?
No.
Just we are defining the functions and calling the function like C programming. Remember in the C programming,
Yeah.
we define the functions, we call the function, right?
Yes.
But we are not using any function here, any object here. Why? Because it is static. So what is the meaning of that? The logic is that, let me tell you here, okay? First static, okay? Let me explain you the static features here. If functions or blocks are static, okay, it can be called directly without any object reference. If functions or blocks are static, it can be called directly without any object reference inside another static function or block. Can you define what I'm trying to say here? You define what I'm trying to say here?
Yeah.
Yeah, what I'm trying to say.
If at all we are calling it in any other objects, then we do not have to define the object. We can directly call the function.
So what we are trying to say basically, in any programming language, I'm not saying about only the Scala, okay? In any other programming language, if there is a static keyword, okay, like functions or blocks are static, correct? So those functions and blocks can be called directly inside any other place wherever the static is there, correct? Without any object reference. So example is that, let's say I'm saying one example, I'm not, I don't want to write here. Let's say here I'm saying def static this is one function, correct? And what is the main function? Main is also static, right? In Java.
Yes.
Remember, do you know? Public static void main, correct? Now inside this main functions, if I'm going to call this, I can call directly this here, right? In Java also, correct? Why I'm calling this here directly in the main? Because this is what? Static. And main is what? Static, right?
Yes.
So static functions can be called inside another static function directly without any object reference of. That's why I'm saying if functions or blocks are static, it can be called directly without any object reference inside another static function or block. It makes sense? Or doubts?
No.
If you have doubts, please let me know.
So by default, main is always static. Is it in?
Yeah, correct. So main is always static, correct? Absolutely correct.
Okay.
Okay.
Yeah.
Fine. So
Yeah.
even you can see here, see this main function, correct?
Yeah.
What is this main function here? What is this?
Final.
So final means first static, then final. Logic. Final means it's a static plus constant. You got my point?
Okay.
See, I'll tell you. Let me tell you. Suppose I'm declaring, I'm comparing with other programming, same time, okay? Suppose I'm saying here static in Java, static integer a is equal to 10, okay? And then I'm saying here final static integer b is equal to 20. What is the difference between both? Or I'm saying here final integer c is equal to 30. Now, see, the static integer a means this value can be changed, okay?
Okay.
And the final means value cannot be changed. It is a constant.
Okay.
But the final variable is itself a static. First static, then constant. You got my point? So B and C are the same, no changes. Only difference is that in the B I'm using the static keyword and in the C I'm not using the static keyword, but internally it is static itself. You got it now?
Yes. Yeah.
Or confusion?
No, no, got it.
Sure.
Yeah, yeah.
So static means the value can be changed. I'll be back again. The static. Okay. Today we'll complete this. The final static integer b means basically the b is a constant variable, right? Which has 20. It cannot be changed. But internally in the background, you can see it is a final and a static, correct?
Yeah.
Similarly, the c is also constant. But in the back side, you can see, you can imagine it is nothing but the final and static.
Yeah.
Okay, you got the point here?
Yes.
A static and final. Now, point is that here in this program here, so what I'm trying to say, wherever we are going to call, it must be the static. That's why in this program right here, in this program, see, we are able to call this a static here directly without any object, right? Even I can call right now, I can say a println, right? Interest rate is equal to plus int rate. See that? Now I'll compile this program. Correct? You got now?
Yeah.
So this is the flow. So here, if we are defining any variables and the functions inside the Scala object, we don't need to call as a with object, right? We can call directly without any object reference because these are the static in the nature, right?
Yeah.
All the variables are statics and all the functions are static. That's why we are able to call these functions a variable to use without any object reference, right? Inside this Scala object company. Any questions here?
No.
Okay. Now let me come to the memory. Why, how it works in the logically, okay? So in this, let me take it up here, Java virtual machine, okay? Java virtual machine here. So whenever we write any Java program and a Scala program, they use a Java virtual machine, right, to allocate the memory, correct?
Yes.
Virtual memory. Even for Scala, right, Spark, whenever we run, we get the JVM error, right? JVM memory,
Yes.
out of memory exception, Spark. So that is the JVM. I'll give a very simple information here. So this JVM has a two part in the memory, okay, mainly, okay, here. So here we have a two part. One part is known as keep and one part is known as stack. Okay, keep memory and stack memory. You know. So whenever we create any object, let's say I'm creating one object here in my program. Let's say like I have one class, okay? I'll create one class here. Sorry. I'll create one class here. Let's say I'll say project is my class. Client project is my class. Fine. I got the class here and I have got the company here. Now inside this company, what I'm going to do here, I am saying is the var Dhiran is equal to, okay, new of project, client project, right? What I'm doing, I am creating one object Dhiran, okay? I'm creating one object Dhiran who is walking to this client project, correct? Client project is a class. Now point is that if Dhiran is an object, but this integer rate and loan rate are what static variable, right? Okay, in this object. Similarly here, in the client project, I have some other variables here. Let's say here, project name, right? The had project name is called null, correct? I don't know the project name. Similarly, I'm saying here the var project location is equal to initially it is null. Initially it is what? Null. Now, when I'm coming to the company here, I am creating one dheran object here, and in that cases, the object of the class, that object is a part of the dheran will be the part of this heap memory.
Hello.
Dheran, right? Hello.
Yeah, yeah. There was, I think, some network issue. I was not able to hear. Yeah. Now it's good.
Okay. So this dheran is a heap memory. What is dheran here? Dheran is an object. Similarly, I can create more object. Let's say like Amit also working to this project. So I can say the where Amit is equal to new of client project. You know. So in these cases, this Amit is another object here, which is a part of my basically heap memory, right? Amit, right? So what we can say? All the object, whichever is being created, the memory allocation for the object is a part of the heap memory inside the JVM, correct? Then
Yes.
now we have two objects. We can create 100 object.
Yeah.
Whenever we are going to create any object of the class, that object is a part of the heap memory. That's why we get this exception also. If we like, suppose if you have created more object and memory is less, in that case you will get a memory exception for the heap memory exception. Okay. Now.
Yeah.
Stack memory. So whenever we are loading the class, so what is the class we are loading here? In this place, whenever we are loading our class here, let's say we are loading what? Object company, right? This part, right? Along with that what? Plus class client project. So all this a Scala object or all the class is a part of what? Which memory? The stack memory, correct? So here I can have class client project here. Then I can have your object company. But now here. So whenever we run the program, okay. So there is a one class in Java, bootstrap loader, okay, bootstrap loader, which loads your class from your local system to the JVM, right? Who is loading our class in a Scala and Java? Bootstrap loader class. It is a default. It is defined in the library. Okay, we are least bother for that. So whenever we run the program, first it will load our class and object whatever we have written in the local system after the compile time to the stack memory, right? Okay, the first steps. After loading this class into the stack memory, we are creating object of the class. Here we are creating object of the class. So this object memory allocation is done a part of what? Heap memory, right? So the from here it is going to allocate memory at this point right here, correct?
Yes.
Got the flow? Now we have two more variable. What variable we have? Integer rate and the loan rate. Okay, so this integer rate and the loan rate is a common informations to all the customer or different? Interest rate for the bank will be same for every customer. It is a different customer to customer.
No, it will be same.
Agree, right? Suppose if somebody has a saving account in the bank, the interest rate on the saving account 4% or 4.5% as per the RBI, it will be so common or same to every customer in India, correct? Similarly, if somebody is going to apply the home loan and they're looking for 40 lakh slabs or 1 crore slab, so the slab wise the loan interest rate is also same for all the bank. I'm not talking about the processing charge. I'm talking about the interest rate. Okay. Yeah. Now somebody is going for the insurance policy. Even for the insurance policy for the premium also will be the same, depends on the age and some of the criteria. Okay. Now, so in that cases, if the variables are common, if the values are common to all the customers, that value should be assigned, should be part of the static variable. You got it now?
Yeah.
Example, I told interest rates, interest rate, I told loan rate. So this interest rate and the loan rate is what now, correct? What we have defined? We have defined what? A static. So a static means it is a part of the stack memory, not the heap memory. Clear now?
Okay.
See, you understand the flow. This is very, very important for us. If you understand this, you are mastering the programming. You will not face performance wise, optimization wise. Okay.
Yeah.
Now, let's say I have created two variables in this class. Which class? Client project class. Project name and the project location. So project name and project location can be changed for the employee or not.
Can be changed.
Suppose, yeah, in a one company in IBM, they are the 1 lakh employee. All the employees are working for the same project, same location. No, right?
No. Yeah.
Okay. Even the client name, right? Let's say here I'm keeping one more where client name, correct? Even the
Okay.
client name will be changed. Where technology, right?
Yes.
Also will be changed, right?
Yes.
These four variables will be the part of it. These four variable like project name, project locations, client name, and technologies will be changed. I'm not saying 10 employee can work for the same project, same client. Next 20 employee can work, but not all the employee will work for the same location, same project, same client, same technology, right?
Yes.
We are saying they are the group of peoples work for, let's say, Honeywell client. There are some group of people who work for Visa company. Some company work for the PayPal because IBM is a service-based company. So in that cases, we have to define the group of people. Group of people means the user, right? Object, correct? Group of people means what? Employee of the company, object of the company are going to work on different projects, okay, for different client. Clear now? So it
Yeah.
means these all are the variables will be the part of your heap memory, not the stack memory. Okay. Why it is heap memory? Because it will be specific to the every employee of the company, not like one common to all the employee. Correct. So in these
Okay.
cases, whenever we are going to create any object, I'll come back in OPS class. So don't be give too much pressure today, Dhiran. Okay, we'll be back
Yeah.
in
Yeah.
OPS class.
Yeah.
Okay, I'll be back. Okay, no problem. I know I'm teaching today, like I've gone in like very high level, but I wanted to give you heads up
Okay.
of a static difference. Okay, so
Okay.
non-static variable, these are non-static, correct? These are what? Non-static variable. Okay, so non-static variables, which is a part of my class, right? Class
So,
client
Amit, one
project.
question.
Yeah, yeah,
So, whatever variables we define inside an object is always static, right? That is what we discussed.
correct,
So,
correct,
inside a
correct.
class, whatever variables we define inside a class, that is non-static, is it? That depends on
Right,
the
right.
depends on whether it is val or where, is it?
Yeah, yeah. No, all are non-static. Yeah. Val means it is a static. It's a constant, right? It cannot be changed. Yes.
Right.
Okay.
So we can we define val here inside a class?
We can define, but not recommended.
Okay.
Okay. No matter. It is same thing. So here now we got the var, right? Client project, project name, project locations, client name, technologies. So in this every object, right? Because I don't have much space here. One location will be for this. So in the memory, now how many variables we have? 1, 2, 3, 4, right?
Yes.
Okay. So the four memory allocations will be done for Dhiran, right? In the Dhiran memory, correct? 1, 2, 3, and the 4. You got my point now here? Similarly, 4 will be for Amit also, right? I'll say a
Yes.
1, 2, 3, 4. Clear now? My project might be different, your project might be different, might be location is the same, client may be the same, client may be changed, technology may be same, may be changed, no matter, right? But finally you can see Dhiran dot project name, Dhiran dot location, Dhiran dot client name, Dhiran dot technology, at least we'll come to know, right? Similarly, Amit dot project name, Amit dot project location, Amit dot client name, Amit dot technology, we'll come to know.
Yes.
But if I want to print Amit dot interest rates and Dhiran dot interest rate, it makes any sense? No, right?
No.
Why? Interest
Common.
rate is same for all, common. That's why we are keeping as a static. We don't need to call with object. We may call, will not get compile time error and all, but not recommended. No use, right?
Yeah.
Okay. So now what is the difference here? Non-static variables will have the memory allocations with reference to number of object, correct?
Got it. Yeah.
Static variables will have only one memory allocations for all the object. Correct?
Yeah. Yeah.
Suppose tomorrow interest rates get revised. It got changed, right? Based on the repo point by the bank, based on the IBA policy. May it be the interest rate they have increased or they have decreased. I don't know. Loan interest rate got increased or got decreased. So every quarter they revise. So in that case, can we go and change every customer of the bank? No, right?
No.
Try to understand the real-time use case, Dhiran here.
Yeah. Yeah.
If every quarter the value is changing and we should reflect to all the customer, existing customer, new customer, correct? For the bank. New revised loan rate. In that case, it must be the static. It cannot be like non-static, right? In my project. Similarly, suppose company is announcing some bonus amount, okay, for all the employee. They have made some slab, okay, whatever, or let's say a bonus amount. So bonus amount also we can keep as a what, a static variable, because bonus amount mainly will be fixed to all the employee. Like in IBM, we had the blue point. Okay, so generally every employee gets 300 blue point. Okay, internally. So in that cases, we have to go for what, a static variable.
Yeah.
Okay, so now non-static is a part of your object memory allocations. A static is a part of the stack memory allocation, which is called all the object, millions of objects, the customer of the bank, right?
Got it.
Any
Yeah.
doubts here?
No.
Okay, so in these cases, we discuss exactly the static variables, non-static variables, singleton object, a Scala object. We discuss about how to call those objects, variables and methods inside the object itself. Correct? We discuss now. We discuss about app and main function just now. Okay, so we are good here. Heap static, we are done. Okay, let me save this file. Okay. Okay. So this is we are done here. The basic flow, basically how to write, how to execute, what is the var, right? And what is this mutable variables, immutable variables we discuss. We discuss about the app. Okay. So we discuss so far what we learned. Basically, what is Scala object, correct?
Yeah.
We discuss about the static, var and functions. We discuss about non-static, var and functions. It is same, right? Logic is same. Then we discuss about app, main functions, when to call the main functions, when not to call the main functions here. Now we discuss exactly how to call functions and variable inside Scala object. Clear now? Right? The other points we discussed. Clear?
Yeah.
So far? Okay. Then we
Yeah.
discuss about JVM, virtual machines, memory allocations, how you protect the memory. Fine. So I'll be going to the next sessions. I'll be completing class and object. Okay. First, before going to any program.
Because yeah, like when we should use class and when should use the
Object.
object.
Yeah. I'm coming that. Okay. So that then you'll have much more understanding. Once again, let me. I'm not okay for me, right? Sorry. Okay, I'll stop now. I will go for the next